Cable TV, water, sewer, gas, fiber optic, all these things are essentially a spider's web underground that most of society takes for granted. Working excavators hitting buried utilities is a major problem in the US. Every 60 seconds, somewhere in the US, an excavator inadvertently hits a buried utility. Operator needs to know where not to dig. So half the problem is until when or how far should I dig, and the other problem is what should I avoid on the way. By law, you're supposed to call in every state an organization like MISDIG. Folks who own buried utilities, like say the telephone companies or electric companies, they come out to the site and they spray paint the locations of where their lines are buried. But the issue with that is as soon as the top surface of the soil is scraped, then you lose those markings. So the operator is flying in the blind at that point. This particular research project is working on technology that will retrofit an excavator to provide this information to the operator while he or she is working. So this system called SmartDig currently consists of a very few things that include a set of cameras that are off the shelf that we have combined or linked together at specific angles so they are able to look in multiple directions, and a set of fiducial or visible markers that we place at specific locations on the site as well as on the machine. Once these markers are placed on the site and the machine, the camera network is able to see these markers and then using this information able to triangulate or locate where the location of the excavator's boom, stick and bucket is at any given time.
So this is the West Quad renovation project, and what they are doing right now is installing a new water main system. Because in an excavation project, they need to worry about the grade of the profile of the trench, and that's what they are doing. They're trying to have a human grader checking on each point, make sure it conforms to engineering drawings. What they usually do is setting up a laser system and then send someone down the trench using a laser eye, try to measure the exact depth at a certain location. Having less people down in the trench, I mean, that can just limit a lot of safety hazard. And one other thing is baffling productivity. Imagine eventually in the future, you don't need someone down the trench to measure the grade, and then they don't have to dip such a wide angle for the project. They can just keep it straight and moving very fast. People trying to solve this problem before because they're using a lot of sensors and also put a GPS on top of it. For the GPS to work, you need a clear view of the sky. Not like in an urban environment like this, you have trees and the buildings around that can jeopardize your system accuracy. For our system to work, as I mentioned, it just needs to set a benchmark, have a sign on the machine, so everything is working locally. And also, our system, in terms of the cost, is at least 1/5 of the price of a high-accuracy GPS system.
Because now we have created a circumstance where the machine is aware of its own articulation or its own state at any given time while it is digging. This work has significant implications in autonomous robotics, meaning an excavator that would be able to dig without an operator being present. It is very conceivable that a computer in an excavator's cabin, in lieu of the operator, can digitally read a digital terrain model, understand where it is located at any given time, where the soil to be dug is located, and where it is supposed to fill the soil at, and use this information in combination with our technology to fully autonomously conduct this excavation.
You don't need to water it because it's meant to live there. The type of lawn we use, which is usually fescue, ryegrass, and Kentucky bluegrass, not only is this grass